Hey guys, welcome to section 7 where we're going to be looking at neural style transfer, which is a really cool concept that you can do in computer vision and I think really kind of pushes the boundaries of kind of what's artistic and really what computer vision is capable of. So this is just going to be a quick video where we're going to be looking at an introduction to neural style transfer. So firstly, I guess it's important to ask, what is style? So from an artist point of view, I guess you can kind of conceptualize style as a kind of signature or unique local kind of representation of what the image is doing. So the high level structure doesn't really change when you change the style of an image, but often there are these kind of features that are present locally in a patch that depict what is the style of an image. So this might be like, I don't know, pointillism, or you've got straight lines, etc., that are common in a lot of these artists. Now, often what we might want to do is we might want to say, okay, well, let's take the style of these artists, say like Picasso or something like that, and then we want to apply it to a new image. So this is all kind of very meta to a certain extent, and allows us to kind of do some funky stuff that we can't necessarily do in our heads. But let's not kind of restrict ourselves firstly to images or paintings, for instance. Let's say you have a photograph of a street and you take that photograph at various times of the year. The structure of the image will often be the same. However, the style might be different. So if you take it in winter, it might be very dark sky, could be at night, or snow perhaps, whereas in the summer it could be very bright, etc., etc., things like that. So we can also apply style to kind of weather, etc. But I think applying it to art is a lot more interesting and a lot more exciting. So transferring the style. So what we essentially want to do is combine the structure of one image. So we've got a structure of this door here, and we want to combine it with the style of another image, so this mosaic here. And then you can see that when we combine the two, we get a kind of mosaic-y door. So how do we do this? High level, our structure will look like this, where we just have a stylizing program that takes a door, an image of a door, and an image of a mosaic. So a content image, we're going to call it. So the content image is the door, and the styling image is the mosaic here. And somehow we're going to combine the two. So what we're going to do is we're going to have a neural network, okay, that's going to extract context or content features from the neural network and combine those with style features from the neural network of another image, okay? Now it's important to know that the neural network is the same in both cases, all right? And what we're just going to do is we're going to extract the features from the context, so the structure of the image, and then also extract the features from the style of an image. Now, features are just the outputs from the convolutional layers, okay? That's all they are. So there's nothing special about them at all. But that's what we mean by features. So how are we actually going to generate these stylized images? Well, what we're going to do is we're going to perform some optimization on an input image, okay? So we're going to take a content image, pass it through a pre-trained neural network to get context features. Okay, I'll briefly explain what features are in a second. We're then going to pass the input image through the neural network to get the context and also to get the style, okay? We're then going to pass the style image through the network just to get the style. And then the idea is then that we take a loss between the styles. Okay, so we're having a distance measure between the style of the input and the style of the stylized image, and also similarly for the context image and the context of the input. And then what we're going to do is we're going to perform gradient descent on the input image to update the input image such that its context is similar to the context of the context image, and its style is similar to the style of the stylized image, okay? And that's all that's happening. So instead of optimizing the weights, we're going to optimize the input. So we pass all the gradients back through the network to the input. So I briefly mentioned features, and all features are outputs of convolutional layers in the neural network. So just bear that in mind, and that's all you need to keep in your head. And that's it, really. That's how we're going to perform this stylization, right? So we're just going to make the style of an image similar to the style of another image, and the context similar to the context. And we're going to do this just by looking at the features.